Hello all and welcome back to this course on digital systems. So in this week we have been looking in great detail the idea of Karnaugh maps and Boolean simplification. So I thought it was a good point in this course to actually look at how you take a practical problem in the real world and how you would use the ideas of Boolean algebra and digital systems to go ahead and implement it in reality, right? So problems in the digital world uh, are not given to the designer in terms of a truth table, right? If you have the truth table, then it's easy to design, Boolean simplify and so on. However, the problems are given in terms of high level problem definitions, which is basically communicated in either the English language or some native human language. So that needs to be translated, right, into a truth table, and then you need to go ahead and implement it. Okay. So let us look at the example of a car. Okay, I want to build a control unit for the car, right? Just before I even begin, let me tell you that this control unit can be implemented either in software, right, or in hardware. Okay, but we are just looking at the case if we were to implement it in hardware, then what is it that we have to do, right? So anyway, so let's look at this. Okay, I'm going to talk only about very simple functionality just to give you a feel. Okay, so I'm going to look at control unit of the car. Right now, this needs to have certain inputs. Okay, let me just put two arrows here, for example. Right, and it is going to have certain outputs. Right now, what are the inputs that this control unit will take, right? So of course, because we are talking of a car, there needs to be some sort of a sensor that is going to sense something, and then it is going to tell us, whether that that event happened or not. Okay, for example, I am going to consider two cases. Okay, one is seat belt indicator, right? And the other thing is basically the idea of door indicator. Okay, a door indicator is basically used to highlight if a door is open or not. Okay, so essentially there has to be a sensor, one for the seat belt, where when you buckle the seat belt in, some switch will close and it will tell you that this seat belt is has been strapped correctly, right? So therefore we are going to assume that such a sensor exists and a Boolean variable will convey that particular information to us. Okay, now how does this these two indicators, what is the English statement that will be given to the designer in the first place, right? Very loosely put, it will say that the seat belt indicator should go on, right, to indicate that people have not put it on. Okay, if any one of either the front passengers, the driver or the person on the other side in the front has not put on the seat belt, right? So this is the first thing. Second, the door, if any one door is open, right, then you will basically have to indicate that some door is open, right? So there is an LED that will glow in the car, which basically says some door is open, and it's up to the driver or whoever in the car to figure out which one is open and shut them. But you just need an indicator exactly to show which door is that a door is open, right? Now the implicit thing in this is, okay, you go ahead and you just switch on the car, right, but you have not turned on the ignition. So the fact is, all these checks, right, need to kick in only when the ignition is on. Okay, so the primary thing is when you just turn on the car, it's okay because you might be getting into the car, people might be keeping their luggage inside, you will not be wearing your seat belt at that point, right? But when you turn on the ignition, these checks need to kick in, right? So therefore, another important input, right, is the ignition itself. Ignition status, is the car on or off, right? Therefore, first of all, this control unit will figure out how many inputs we need. So we obviously need a door indicator, right? That is, there are, let's say, how many doors? The front, two of them, back two of them, and the boot, right? So you have 5 indicators. So therefore, I am going to indicate this by, how many inputs do I need? Seat belt indicator, yes. So I need, let me write the inputs here, right? Number of inputs I need for the front 2 passengers, I need 2 indicators. Door indicator, there is going to be 5 and ignition is 1. So if I look at this thing here, I'll have ignition. Okay, the ignition is basically indicating if the car has been turned on or not, and the seat belt indicator, I need 2 inputs. So I'm going to draw a line here and say 2. Okay, so I'm going to call this S1 comma S0. Seat belt 0 is S0 is for the driver's seat, S1 is for the person beside, right? And I'm going to have 5 inputs here, which basically, so I'll call this S1 to S0. This is going to be D4 to D0. D0, okay, and I'm going to have 2 outputs, okay, and D0, I'm just assigning it again to the driver's seat, the door near the driver's seat. Then D1 is on the front, the back 2 and the boot. D4 is for the boot. So I'm going to have an output here which is basically called seat belt okay. This is some LED that has to glow, okay, and then we are going to say door. Okay, we are going to call these outputs as seat belt and door, and essentially that's going to indicate that one of the doors was open, the seat belt was not strapped, and so on, right? So based on this description, why don't we first go ahead and build a truth table for this? Okay, ignition S1 S0 D4 D3 D2 D1 D0, right? I have so many inputs, and I'm going to call, let me call this seat belt and DR, okay. DR. So first of all, what we'll do is, suppose the car is off, ignition is off, right? Then it really does not matter, okay, so what the status of these things. The driver could have fastened the seat belt, or the front door could be open, closed, it does not matter. There is nothing to indicate here because the car is not on, right? And therefore you simply need to say the seat belt indicator need not go on and door indicator need not go on, okay. So we are assuming that the seat belt indicator will go high if one of these people have not put on this, fastened the seat belt when the car has been turned on, when the ignition is on. Likewise for the door, okay. So it's interesting to note that we are now using don't care for the inputs. So you will see this in actually certain data sheets of ICs. It does not matter what the state of. So this is actually has a very similar meaning as to what we had used for the outputs. We don't care what the output state is, right? Same way we don't care what the input state is for these 6 or 7 Boolean signals here. The output SB and DR has to be 0, right? And then when the ignition is turned on, right, we can do the following. We can go through 0, 0, 0, 1, 1, 0, 1, 1. Now again here it is interesting to note that we will basically be saying it does not matter what the state of the door is. Okay. So most important thing is for us to recognize, even though this control unit is accepting, if you look at the control unit, it is accepting 5 plus 2, 7 inputs and the ignition, but it is not, we don't have to strictly design it as if it were a 2 power 8 truth table design, because we are saying it does not matter what the state of the door is for that, right? Now, so what we need to now do is the S0, S1, yeah, okay. So I will just look at the seatbelt indicator here, right? 0 means seatbelt has not been fastened, 1 means seatbelt has been fastened, right? So if it is 0, 0, right, both of them have not fastened it, seatbelt indicator needs to go high, right? Only when both have fastened it, seatbelt indicator needs to go low and it will be off, right? Now, what is the state of the DR? Well, that's an independent thing. So I am not going to worry about the state here, right? I am not going to say, because really the state of DR depends on what the state of D0 to D4 is, right? And therefore I am going to write that out separately. So now I will say I don't care what the status of the seat belt is, okay? And I am going to go through 32 combinations, okay? All 5 doors are open. So D0, okay, let me maybe write that S0, S1 goes high when seat belt is fastened, right? Similarly, D4 to D0 high when door is closed, right? So when the door is closed, it is going to be 1, right? If any one of the door, if the door is open, it is 0. So 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, 1, right? So again, what we are going to say here is the DR indicator, if any one of the doors happen to be open, right? Any one of this happens to be 0, the DR indicator has to go high, right? And therefore, you are going to say 1, 1, 1, 1, 1 all the way except for the 32nd entry, which is 0, 0, 0, 0, 0. When you say the DR signal has to go to 0. Of course, the ignition has to be 1 all through in this, right? So effectively what we are therefore saying, right, what do we mean by this whole thing here? It basically means that inside this control unit, I have a block that controls the seat belt, that takes the ignition input and this seat belt input, right? Two signals, and simply controls this. Likewise, I have another block which is independently controlling the doors, that is doing this, right? And the ignition is obviously going to both. Okay, I'll just write that here. Ignition is going to control both of them. So therefore, we can look at this, okay, S1, S0 and seat belt, right? So this is 0, doesn't matter, output is 0, 1, 1, 1, 1, and therefore this is going to be 0, 0, 0, 1, 1, 0, 1, 1. So this is seat belt indicator on, 0. Okay. So the key point, remember, is that this cannot be taken out of the picture. I mean, we cannot ignore this, don't care. We have to consider it because the ignition is a very critical input to that particular block, right? And therefore, I have to look at this as a 8 variable truth table, right? That means now my SB can be written as summation of, so this is 0 to 3, output is 0, this is 4, 5 and 6, 4, 5 and 6. This is effectively what we have. So now what we can do is we can go ahead and build our truth table if we want. The ignition is out here, S1, S0. So S1 bar, S0 bar, S1 bar, S0, S1, S0, S1, S0 bar, 0, 1, 3, 2, 4, 5, 7, 6, right? And this is ignition 0, 1. So obviously for 0, 1, 2, 3, it's all 0, and all I have to do is 4, 5 and 6, right? This is what I have, and therefore I can go ahead and do this thing, and also okay, I can also do it in these two circles, and therefore I can write SB as S1 bar, okay, into IG plus, right, I'll say plus S0 bar into IG. This is what we have, and therefore if you look at this, it will basically be IG S1 bar plus S0 bar, IG into S1 S0 whole bar, which is basically nothing but a NAND 2 gate, okay. But it is not sufficient if I just take S1 S0 and put it through a NAND 2 gate, S1 S0, right? I also need to then AND it with ignition. Only when that goes high will this SB be a valid implementation of what we want here, right? So now what we then have, of course, we go ahead and do a very similar truth table for the other case, which is the door. Okay, ignition D4, D3, D2, D1, D0. I want to look at DR, of course 0, doesn't matter what this is. Okay, now remember, we are dealing with a 6 variable truth table. Okay, this is a 6 variable truth table, so therefore we will actually have 2 power 6 input combinations. Of course, the dr has to be 0. If it is 1, 0, 0, 0, 0, 0, you just have, it has to be 1, 0, 0, 0, 0, 1, it has to be 1 all the way down, 1, 1, 1, 1, 1, 1, right? Only when all the doors are closed, right? So what did we say? We said it goes high when a door is closed, right? It goes high when a door is closed, okay? And therefore, only when all 5 of them are closed will you be able to say that the dr has to go low, okay? So effectively, this dr will be summation. Of course, 0 to 15 there is nothing, 16, 17, 18, all the way till no, how many? These are 5. No, I am not talking about 16, 17. Sorry. D0 to D4, all combinations is going to be 32, right? So 0 to 31, there is nothing. So 32, 33, all the way to 62. This is what we will get. And effectively, if you solve this, this will exactly be another NAND gate for how many? For all the 5 inputs. D4, D3, D0, you get an AND gate, right? And then you are going to do an AND with the ignition. And this is your door controller, right? So this is sort of one interesting solution to this particular problem, okay?